Bienvenidos, Ushamdeed, and welcome Anne Arundel Community College learners from the CTS-131 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy's Switching, Routing, and Wireless Essentials, or the SRWEv7 course curriculum. And in this activity, we're going to be taking a look at the modified in-class lab, which we'll be doing in Packet Tracer, and it's going to be lab 8.5.1, where we're going to be configuring DHCPv6. And so you have the lab in the course room, and this is the topology that we're going to be working with, and there is the addressing table that we're going to be setting up, and actually which I've already gone ahead and set up to save us some time here so that we can jump right in to the Ipv6 configuration portion. So all the Ipv6 addresses on the routers have been configured. The switches here are really serving no other purpose than to simply provide a break between the PC and the routers. And all of our configuration work will be on the routers until we pull the PCs up to get that DHCPv6 address. Now, this is an amazing activity where we're going to be looking at Stateless Address Autoconfiguration, or SLAAC, where there is no DHCPv6 server involved, either stateful or stateless. With SLAAC, we will automagically, due to the router solicitation and more importantly the router advertisement messages, get an Ipv6 address, which we will have EUI64 coming into play. And I'll detail the EUI64 and what that's going to look like. And so right now, what we're going to do is we're going to kick off here. I've already done part 1, step 1, and 2. We're going to start with step 3. And step 1 and 2 was simply putting some basic configurations on the router, such as the IPs, as well as no IP domain lookup and logging synchronous. So we're going to configure gig 000 and gig 001 with the Ipv6 addresses, which again, that's already been done. And now we're going to configure a default route on each router. So here we are on router 1. Let's go from user exec to privilege exec, and then we'll get into global config. And we're going to do a default static Ipv6 route. So :/0. And on router 1, it's simply going to point to the IP address of the router 2 interface. So 2001:db8:acad:2:2. And if I was to say do show Ipv6 interface brief, we can see that gig 00 interface that we are 2001:db8:acad:2:1. In fact, let's test. Can I ping over there to the 2001:db8:acad:2:2? Let's make sure we've got connectivity to that next hop IP address that we're going to be using. And then finally, let's come over here to router 2, and let's go into privilege exec from user exec and then into global config. And we're going to do much the same thing here, Ipv6 route :/0. And that's the equivalent in IPv4 of saying quad zeros space quad zeros. So we just get away here with a :/0, and we're good to go. And so this will be, 2001:db8:acad:2:1. And that is the IP address which we just saw over on router 1. Now again, if we can ping from one side, we should be able to ping from the other side. And we do. We've got full connectivity. So let's go ahead and save our configurations here on the router. There's one more command we need to run, but I'm saving it for a specific purpose. So now what it's asking us to do in part 1, step D is to save the configuration, and we've done that. So now we're into part 2. And what part 2 is asking us to do is to check the PCs to see that SLAAC is actually working. So let's come over to PCA, and what we're going to see is that it is not working, right? So let me come over here to automatic, and you can see nothing is happening. And while we're waiting there to make sure we give it plenty of time, let's come over here and let's come over to AutoMagic. And you can see for IPv6, we are not picking up any SLAAC information. And I wanted to highlight this point because this is very important. You'll notice that I was able to put in a default IPv6 static route, and I was able to configure all the IP addressing on the router interfaces for both router 1 and router 2. However, I can do that, and I'm not going to see any error messages or any indication that something's wrong. However, you have to enable IPv6 unicast routing. If you do not enable IPv6 unicast routing, the router is not going to send router advertisements. And here's what I mean by that. So let's get Wireshark open here, and we're going to jump onto a real Cisco router. All right, so here we are on a real Cisco router, and now what I'm going to do is I'm going to show you the importance of that IPv6 unicast routing command. Without that command, you are not going to have the router sending router advertisements to a LAN segment. To advertise the prefix, the network portion of the IPv6 address, so that then the host can use EUI64 to formulate its own statelessly auto-configured SLAAC IPv6 address. And so let's see what that looks like here. And I've got Wireshark running, so we'll look at a capture as well. So let's get into privilege exec, and I'm going to say show run, and I'm going to pipe it to include unicast to prove that I don't have IPv6 unicast routing on. However, if I say show run, interface fast Ethernet 00.10, and this is an interface that we are snooping the packets on, so to speak. So I'm seeing the traffic that this interface is generating. Here's our link local IPv6 address. Here's my global unicast /64. And this is why it's critical that you're using /64s where you're using SLAAC, because that is how it's going to do the EUI64 process to come up with that address, right? That SLAAC address where we have no DHCPv6 server at all. So there's the interface that we're going to be snooping the traffic on. You can see that we don't have IPv6 unicast routing enabled. So when I come over here to Wireshark and I kick off my packet capture, we're not going to see any router advertisements, right? And so now let me go ahead. Let's come over here, and I'm going to go ahead and kick off IPv6 unicast routing. And what you're going to see, as soon as I hit enter there, you can see we're generating all kinds of crazy traffic here, right? We've got TCP going bananas, but it's ICMPv6. That's the protocol. And you can see here's my neighbor solicitation, right? And we're getting neighbor solicitation messages, excuse me, that we are receiving from another source because we've enabled, we've enabled IPv6. I had to scroll down a bit there, and let me go ahead and stop the capture here. So here is, you can see we've got lots of router advertisement information going on. Who's the source? Well, it's router 8, right? FE80::8. That is router 8. And router 8 is generating this router advertisement message that it's either auto-magically being advertised, or it could be in response to a router solicitation message. Maybe a host just came up on the network and says, hey, I need an IPv6 address, and I want to get it statelessly. I want to use SLAAC. And so it could be in response to a router solicitation message. But at the end of the day, it's the router advertisement message, and we come all the way down here. There's the prefix information. And so now we transition back to the packet tracer activity. And so what we're going to do here is we're going to take a look at turning on IPv6 unicast routing. So again, I just showed you why we have to have IPv6 unicast routing on. And the reason for that is that we will not have router advertisements or router solicitation responses unless we have IPv6 unicast routing on. So now when we come out here to PCA, take a look at what just happened here. We get an EUI64 generated address, and now the automatic stateless address configuration is working, right? So stateless automatic address configuration SLAAC is now functional with IPv6 unicast routing on. And that's how that whole process worked out. A router advertisement goes out in response to a router solicitation or periodically. And if a host comes on and needs that prefix information, it gets it. And our PCs do the EUI64, as do the majority of PCs that are out there on the market. They're going to do EUI64 to generate automagically that IPv6 unicast address. So what we could do is we could go to the PC command prompt, and I can say ipconfig/all. And you can see in here that we get all of our IPv6 address information. And remember that it's from the physical layer 2 MAC address that the link local address is configured, because you see that FFFE in the middle, and your global unicast address with the FFFE in the middle. Now, it looks a little odd for the link local, but remember the ::: here is actually representing many zeros, right? Quad 0 hextets, where we can shorten it, right, and do the abbreviated consolidated IPv6 address representation with simply : And so that is how these addresses are auto-magically configured. So now we're going to change router 1 to do DHCPv6 stateless DHCPv6. Now remember, there's 3 types of DHCP that we can use with IPv6. We can use SLAAC, which we just did on both sides. And remember, stateless address autoconfiguration requires no DHCP server, but maybe there's other information we're interested in. Maybe I want to put in a domain name to have my clients pick up, and a DNS server to have my clients pick up. For that, we would need a DHCP server. And routers, Cisco routers, can be DHCPv6 servers. Now, we're going to do stateless DHCPv6. And what that means is I can provide other config information. And the IPv6 address is still going to be generated from SLAAC. But there's going to be other information that we can provide. So here we are on router 1. Whoops, let's get into global config. And I'm going to say IPv6 DHCP pool. And again, the command, just like IPv4, right? IPv1 stateless. And that is going to be our pool. I'm going to put a DNS server entry in here of 2001 DB8 :ACAD : 254. And I'm going to put a domain name in here of stateless.com. Right? Now, we're not done yet, right? Because if we go back to the PC, and actually, let's take a look here. We'll do the ipconfig here on A, because this is where it's going to be changing. So I'll say ipconfig-all. And you can see when we look at the DNS servers, right? None. No DNS servers. What about a connection-specified DNS suffix? None. So no DNS servers, no DNS suffix, right? Like no domain name suffix, like stateless.com, like we would just configured, right? So we still don't have that information. Even if I came over here to the desktop configuration area, and I clicked this over to static, and then came back and said, no, I want SLAAC to generate the address. Do we get a change in the information here? And the answer is no, it doesn't pick that information up. And the reason it doesn't is because now that router 1 is the DHCP server, we need to go into the port interface gigabit Ethernet 001, which is serving PCA's LAN segment. And we need to tell it, hey, in that router advertisement that you're sending out, we're going to set a flag. Right? So we're going to set a special flag in there that tells any hosts that are trying to get IPv6 addressing information automagically, right, that there's other information that's available, and we're providing that information. And so, again, it's as simple as saying IPv6 ND other config flag. right? There's other configuration information that you can get from me. And most importantly, we're going to say IPv6, DHCP server, and then the name of the pool, stateless. And there we go. So those two configuration commands, if I say do show run, that we see on the gig001 interface are, hey, there's a flag I'm setting in my router advertisement messages that's going to tell you I've got additional information for you. And then here's that IPv6 DHCP server, and then the name of the pool, R1 stateless statement, that tells us which pool to use, which you saw right up here. And so here's where they're going to come. The router's going to come to get the additional other config flag information to provide to the client. So now that that's done, let's come over here and let's see if it auto-magically got that information, and take a look at that. There's our DNS suffix, and there's the DNS server information. And that's it. So just like IPv4, we create a DHCP pool for IPv6. We put the information that we want in there. And again, remember, this is stateless, meaning the address is still being generated using SLAAC. It's just that I have a couple additional pieces of information, the DNS domain name and the DNS server address, that I want to get picked up by the clients. And so I would do stateless. So that's the use case for stateless. If you don't care about the DNS information or the DNS server, then you can stick with SLAAC, Stateless Address Autoconfig, if all you need is an IPv6 address. If you need other config information, then you would follow the process that we just did and add these two additional statements right here on the interface that's serving as the IPv6 server. So now we're going to go to the third case. So we've seen stateless address auto-configuration. We've seen DHCPv6 or stateless DHCPv6. Now we're going to look at stateful DHCPv6. And so the difference between stateful and stateless and SLAAC is that with stateful, you are providing the whole enchilada. Everything. You're providing the address prefix that's going to be used. You're going to provide the DNS server and the domain name. So you're providing all of the information that's going to be used. And let's do that on router 2. So I would say IPv6 DHCP pool, and it's going to be R2-, and as you probably guessed, stateful, right? Now, once I'm in here, you can see that we've got some information we can add in. And the first thing is going to be the address prefix. What's the prefix that we're going to use? Now, since we're not doing SLAAC and we're not doing stateless DHCPv6, we don't have to use a /64. Again, when SLAAC is involved, you want /64, right? Because EUI64 is going to generate that interface ID portion, and it's going to be 64 bits. So we stay with a 64-bit prefix length. However, here when we're doing stateful, we've got full control. So I'm going to say 2001 DB8:ACAD:3:AAA:/80. So we're going to make this a /80, meaning the first 80 bits represent the prefix network portion of the address, and the last 48 bits, and that is still a lot of host IP addresses, the last 48 bits will be the interface ID portion, which, excuse me, which we're going to go ahead and see what happens here in just a second. So I'm going to say DNS server 2001 DB8:ACAD:254, and then domain name is going to be stateful.com. Now, just like the stateless DHCPv6, with stateful DHCPv6, we have to go onto the interface that is going to be serving up the clients on this local area network right here to the right of router 2. And we've got to tell that interface, hey, you're configured to be a stateful DHCPv6 server interface. So let's go ahead and go into interface gigabit Ethernet. Gigabit Ethernet 001, and we're going to go ahead and say IPv6 DHCP server. And remember, when we did the other command, I'm sorry, not the other command, the other interface, the command was the same, and we're going to give it a different R2-stateful pool name, right? Because we want to give it that DHCP pool information. So there we go. So we tell it the pool that it's going to be using, and now IPv6 ND, there are the three options, right? Manage config flag, other config flag, and then you've got the RA there, but we're going to leave that to the side for right now. But the manage config flag is when you're managing the DHCPv6 in a stateful way. The other config flag just means, hey, I'm not managing the addresses, I've just got some other configuration information for you. So when the managed flag is turned on, that means that this router is managing all DHCPv6 settings totally, right? It's got total control. So there we go. We've got it set with the manage config flag. Let's pop out here. And so now what we're going to do is we're going to pop over to PCB, and we jump onto PCB, and let's go ahead and take a look at the stateful information that it's going to receive, and it looks like it already did. So pretty cool, right? So if I was to click on static, and we'll see that it happens here, I click on automatic, and there you go. Now, very important here, take a look at the remaining 48 bits. Now, this is not EUI64 generated here. Now, for the link local address, we see the FFFE in the middle. We know that it is because the link local address uses EUI64 even, I should say, in spite of the fact that the global unicast address is that /80. But you can see up here, when you look up here, this is just sort of randomly generated, the rest of the address, the last 48 bits, the interface ID portion for the host, right? Because it's a /80. And we can see that none of these characters really match up, right? And you know that this is sort of the MAC address is the E08FFFE343845. And so that's where we kind of get away from that EUI64 taking place. So let's get into the command prompt to wrap this activity up. Let's say ipconfig-all, and there it is. I've got my DNS server address. There's my domain name. I've got my IPv6/80 address. And we've got the link local address, which was EUI64 generated. And everything is working perfectly, right? So again, to recap, there's three ways that we can get IPv6 hosts addresses. We can do stateless address autoconfig, right? And that is that auto magic process, but we've got to have IPv6 unicast routing on. And that's true across the board, right? DHCPv6 and SLAAC, you've got to have IPv6 unicast routing on, or you're not going to get those router advertisements. Those are those packets in which all that information is kept, right? Those the flags that are set or not set, that's where we get that prefix information. And so you've got to have IPv6 unicast routing on. So you can do stateless address autoconfig, you can do stateless DHCPv6, and then set that neighbor discovery other config flag. And then you've got the stateful IPv6, DHCPv6, which is where you're saying, I'm controlling everything. I'm controlling the addressing. SLAAC is no longer involved with the addressing like it is with SLAAC and stateless DHCPv6. And that is going to do it for this activity, Packet Tracer Lab 8.5.1. Let me know if you have any questions, and I hope to see you in the next video.